A warm welcome. This is Control Systems course lecture 2.5, focusing on the effects of proportional, proportional integral and proportional integral derivative modes of feedback control. Kp, the proportional constant or proportional. From this circuit itself, there is an inverting amplifier along with the sign changer, because inverting amplifier will be providing an output with a negative sign, and that can be changed to a positive sign with the help of just a sign changer consisting of two resistances of same value. Here the same thing has been represented with the equivalent circuit. Here R1 is there, R2 is there, its input is E of t, and let us consider an intermediate voltage known as U1 of t. This is actually U1 of t. And next, this U1 of t is being supplied as an input to the sign changer. Here we have R value, this is also R value. Let this U1 of t be there, and its output is E of t. The actual output of the P controller is U of t and the input is E of t. U1 of t is considered as an intermediate between the inverting amplifier and the sign changer. Here we are going to apply the mesh equation for both the circuits. And for the first circuit, it is E of t is equal to I1 R1, U1 of t is equal to minus I1 into R2. And since we have I1 commonly here, we can just substitute the value of I1 as E of t divided by R1 in the second equation, and we'll get this value. Also, we come to know about the second mesh as U of t is equal to minus I2 into, second sign changer as U of t is equal to minus I2 into R, and U1 of t is equal to I2R. With this, we can see that U1 of t is equal to minus U of t, just a sign changer, that's all. So let us substitute this U1 of t is equal to minus U of t here. When we substitute, the negative signs get cancelled, and we'll get U of t is equal to E of t into R2 divided by R1. Thus, U of s by E of s is equal to R2 divided by R1 by taking the Laplace transform, and this is nothing but the proportional constant or proportional gain Kp, which is equal to R2 divided by R1. This is in case of inverting amplifier. So this will be the proportional constant or proportional gain value of the P control. Next, let us consider the integral controller. The integral controller is a device that produces a control signal which is proportional to the integral of the input error signal. So let us consider U of t is proportional to the integral of E of t into dt. So replacing the proportionality, we have Ki, that is integral gain. And taking the Laplace transform, we get U of s by E of s is equal to Ki divided by proportional integral constant. It is Kp into 1 plus 1 by s into Ti. So this Kp will be R2 by R1 and this Ti will be C2 as in this case. See in this equation, here U of s by E of s for the proportional integral derivative controller, that is a PID controller, the U of s by E of s value is equal to Kp into 1 plus 1 by Sti plus Std. So here we can come to a conclusion that Td value is R1C1. Here the derivative time Td is R1C1. Similarly, the integral time Ti is equal to R2C2. Here we have integral time Ti is equal to R2C2, and the rest here outside, if the Kp value is R2 by R1, so the Kp value is R2 by R1. Upon comparing that equation, this entire term has to be equal to 1. That is what the equation. So let us consider this as 1 is 1 plus R1C1 plus R2C2 divided by R2C2 as equal to 1, the magnitude value. Thus, by varying the value of R1, R2, the value of Kp, Td and Pi can be adjusted. Thank you.